If we look at our classical graphs, okay, we've got 4 of them. So one of them is looking like this. And this should look familiar. This is temperature. Another is looking like this. And this should look familiar as pH. We then have 2 that look rather like this. And here we have enzyme concentration, and we have substrate concentration. And we are going to pause for a moment because I've seen we've got some new names that have appeared on our list. Okay, so just a recap of what a live lesson is. So I'm Helen, I'm your AS biology teacher. And this is a live lesson, which means that I pick or you pick a topic, and then we do a full 30 minutes on it. So the topic for today is looking a little bit more at enzymes, and then looking at describe and explain, and how we take our technical knowledge of enzymes and use it in a past paper question. So if you haven't got to enzymes already, never fear, you're going to learn this. Okay? If you have already got there, or if you've got some knowledge from previous courses, then that's cool. Bear with us, enjoy, ask questions if you want to. In the live lessons, the only way that you have to ask questions is via the chat. So you can type in there and I can try and keep an eye on it, and I'll see if you've got questions. So what we started off here was with our classical graphs. So you've got 4 things that are affecting enzyme reactions. So all of these have a vertical axis of rate of reaction. Okay, and all of them are made from many little test tubes. So for this temperature one, we did 10 different experiments at 10 different temperatures. We plotted all the points and then we joined them. So what you'll often see in your books and in papers is these smooth curves, as if there was no points. But always remember that these were made from like 10 different test tubes or 5 different test tubes, each one at a different temperature, each one at a different pH, each one at a different enzyme concentration, each one at a different substrate concentration. They then plot the points and put the line in. Okay, first thing to remember. Next thing is that we've got 2 groups of graphs here, and there's an important distinction between the 2. So if we think of temperature and pH, okay, when we change temperature or we change pH, we are changing the enzyme itself. So here we change the enzyme structure. And remember, we don't care if it changes the enzyme structure. We care in particular that it changes the shape of the active site. So that is your key phrase. And when that shape of that active site changes, you are no longer complementary to the substrate. And if you're not complementary to the substrate, you don't get your reaction catalyzed. Okay, so this change of enzyme changes the active site. Okay, so we're no longer complementary. And this then affects rate of reaction. So these 2, temperature and pH, all about enzyme structure. On the other side of the fence, enzyme concentration and substrate concentration, here the enzymes are all fully functional. Here it's about availability. Can we make enzyme substrate complexes, because without those, then we can't have a rate of reaction. The more enzyme substrate complexes we have, the more rate of reaction we can have. Okay, so this is about ability to make enzyme substrate complexes. Okay, so that then is our 4 graphs, and what's important to be able to do is to be able to describe and to explain, and to read the question very carefully to determine, must I be describing or must I be explaining? So before we move on to those words a little bit more, but any questions on these classical graphs? Everybody's smiling so early on a Tuesday. Okay, so we have our 4 things that affect rate of reaction. Let's now think a little bit about describing those graphs. Okay, so we have describe and we have explain. So describe, let's keep it relevant to everybody. In my lunchbox is a sandwich and an apple. Just a description. No reason, no nothing, just what is there. I look at the lunchbox, what is there? Explain. Now we need to know, why is there food in the lunchbox? So I get hungry at work, so need to bring lunch. Not the full end of the explanation. That's why the lunchbox is here. Why has it not been eaten yet? I haven't had time to eat it yet. That's the explanation as to why there is food in my lunchbox. So the explanation doesn't tell me what is there. The explanation doesn't tell me there's a sandwich and an apple there. The description tells me there's a sandwich and an apple there. The explanation just tells me the why. So when you are describing, you are looking at what. When you are explaining, you are looking at why. And yes, this does sound like an English lesson, okay? But unfortunately, English is critical when it comes to biology. You have to have a good idea of what you need to do in the question, okay? What is my question word? How do I properly answer this question? Okay, so describing is what, explaining is why. So when we want to explain something, we're not going to be explaining our lunch boxes, we're going to be explaining a biological phenomenon. So we need to have lots of technical terms. And we must have full detail. So this is where you've got to go through your notes. You've got to go through your textbook and you've got to learn the facts. Because if you don't learn the facts, there's not a chance you can use them in the explanation. So you might not be regurgitating them where you learned them, but by learning them, then you've got that ability then to explain. Describing the what is just state what you see. We don't need any biological understanding in order to do a describe question. Okay, because a describe question, for example, this graph, it increases from some value to another value. And then it's constant from some value to another value. This graph increases, we can say from and to, okay, we can say, let's say from to, then we say, this one's got a nice feature, so we can say maximum at. And then we can say, let's just make this a little bit easier to see between. That was that graph. Then we can say decreases from 2. Okay. Another classical thing that they like to put, maybe not necessarily in enzyme graphs, but another classical shape of graph. So we can have like this one, and then it does this. Okay, so here your phrases are decreases from something to something, then fluctuates between, they like that word. Move the chat out of the way. And so see, in each case, we have just looked at the shape of the graph. Is it increasing? Is it constant? Is it decreasing? Is it fluctuating? Is it a maximum? Is it a minimum? And then we add data. Okay, so you're always adding data to these things in order to get the full marks. And that's why they say, using the information in figure blah, 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 describe the effect of blah, blah, blah. So describe the effect of is it increases, it decreases, it fluctuates, it has a maximum at. But using the information in figure blah, blah, blah means that we have to get some data points out. So it increases from 0 to 5. It hits a maximum at 6 and a maximum of 7. Okay, so obviously your numbers would vary depending on your question, but that's where we're getting at when we're talking about a describe question. Okay, so explain why does it increase? Why does it decrease? Why is there a maximum? That's your biological facts. Okay, have we got happy people? Okay, so we have happy people or very slow typing people. So now we are going to move on to some past paper questions, and we'll see how far we get. So I think if I press there, I'm going to press here. Okay, and you should now be able to see a PDF. Okie dokes. So this first PDF, this is winter 2009. It's paper 21, and it's question 2. So yeah, it's 2009. It's quite a few years ago. But the thing is that the questions are all still relevant. Okay, it's still the same content. Okay, in this case, enzymes hasn't really changed much. There is some slight differences in terms of how they ask questions, but the more variety, the better, because you never know how they're going to ask in your exam. So we start with a little story. Amylase is an enzyme that catalyzes the hydrolysis of starch. We should be happy with that from IG. A student investigated the effect of pH on the activity of the enzyme. So, pH. So, already we're thinking of, we should have something like this. Okay. 8 test tubes were set up, each containing 5 centimeters cubed with the same concentration of amylase solution. That's our substrate. So substrate concentration is controlled. It's constant. Okay, and buffer solutions of different pH values. So here is our independent variable. So when you get a question like this, it's great to work through like this because that's also going to help prepare you for your practical paper. Okay, test tubes were left in a water bath at 30 degrees C for 10 minutes. So we have controlled temp and we have same time. So this means that we can actually see the effect of the pH because everything else is constant. So after 10 minutes, 5 centimeters cubed of a starch suspension at 30 degrees C was added to each test tube. So 5 centimeters cubed of a starch suspension, it's the same suspension, so we are getting things very back to front and nobody is complaining. Ladies and gentlemen, that is shocking. This is not substrate concentration here. Amylase is our enzyme. Okay, starch suspension is our substrate concentration. I think you're all sleeping there in the background. Am I talking to myself? Right, so now we have added our substrate. Our enzyme is at temperature, our substrate is at temperature, everybody's happily at 30 degrees C, right? And then immediately, the student took a sample from each test tube and tested a reaction mixture for presence of starch, taking iodine. Samples were taken every 10 minutes, every minute for 10 minutes, and tested in the same way. And there are their results. So, what a lovely, lovely thing this is to try and figure out. But we can do it. So, time in minutes, 0 through 10 minutes, pH 2 through 9, starch present and starch absent. So, just to make it easier, there are our starch gones. Okay, so if starch is gone, that means it's been hydrolyzed. So there's our enzyme activity. Okay, so now we get to some questions. Describe how the student would test for the presence of starch, recapping biological molecules. Okay, so we would add 5 drops of iodine solution to the sample withdrawn. Okay, we're always precise, we're always exact. We don't just say add iodine solution, we give them how much iodine solution. Okay, and it's not iodine, it is iodine solution. It's iodine and potassium iodide. Right, so that is how you do the test, how you know if it's positive. Yellow brown to blue black. Indicates the presence of starch. Okay, so we have fully described our test. We've certainly got 2 decent marks, if not more, in there, so we're happy with our 2 marks. Okay, we described what would happen. So the question was, is every test needed to add 5 drops? I work with a standard 5 as a magic number because it's 5 mils of this, is 5 drops of that. So in some cases, maybe you want to add 10 drops, and you want to add 2 drops. They haven't given you an indication of the size of your sample. 5 drops will probably cover it. So if they tell you in your crack exam then to use 3 drops, then you use 3 drops. You don't say, no, 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 I must use 5. But it is a general good rule of thumb that is quite functional. Right. So next question says, use the axes below to sketch a graph to show the effect of pH on the rate of hydrolysis of starch by amylase. So note that there are no units on that vertical axis. You don't have to go put them in. You can't go put them in units for ticks and crosses. So what we're doing is we're using these axes as is, and we're adding in information to show the relative change. Okay, so when we colored in that table, very nicely, we can see the shape. Okay, so 1, we didn't test. 2, there was nothing. Okay, at 6 was our highest. 9, there was nothing. 10, we didn't test. So we're going to just draw in that classical pH graph as best we can. 1 smooth curve. Okay, no points plotted, just a smooth curve because we are sketching this curve. Done. Okay, so we could have made it slightly fatter because this is slightly fatter here. Okay, we've got a little bit more activity at 4. So I think maybe I would have drawn it a bit fatter if I had that potential of a pencil in my hand and a piece of paper rather than a digital pad and pen. But that's your idea. Nothing up to maximum, down to nothing. So then comes our beautiful question for this lesson. With reference to the student's results. In other words, use the data. Describe and explain. Oh, and look, they put it in bold. So we have to both describe and explain. We cannot get full marks with just a description. We cannot get full marks with just an explanation. We have to do both. The effect of pH on the rate of hydrolysis of starch by amylase. So, effect of pH on hydrolysis. 5 marks. This is a juicy question. So, if you work through this systematically, you've got your 5 marks under your belt, you move on to the next question. So, I rather like these describe and explain questions because they are slightly easier to set out. Okay? What we're going to do is we're going to pick up points to describe, and then we are going to explain why that particular description says. So we have describe and explain, describe and explain, describe and explain. So let's start at the very beginning. We have no hydrolysis at 2 and at 9. So I'm going to, okay, we'll do it. At pH 2 and pH 9, there is no hydrolysis of starch. There's our description. So what's our explanation? Okay, because the amylase is denatured. Right, how did it get that way? Why? Give me the explanation, give me the details. So, hydrogen ion concentration leads to loss of, oh, sorry, that's not right. Extreme differences, there we go, in hydrogen ion. Now, remember also we have to write hydrogen ion. We can't write H+. This is biology, not chemistry. Okay, we have to write them out. In hydrogen ion concentration, lead to what? Loss of tertiary structure, because every enzyme has tertiary structure, and therefore the active site of the enzyme is no longer functional. Okay, so my handwriting is a little bit large on these PDFs, and I'm answering very much in full, so our answer is not going to fit in these 5 lines. The idea is when you're studying and things like that, then you answer in like massively more than the question, because then by the time you get to your exam and you're a little bit worried, you still remember enough to get your marks. Okay, so that is a full description and explanation for those 0 rates of reaction. So, what about here? These next interesting points. Why do we have lows? So we've done the zeros, now we have the lows. So, at pH 3 and pH 8, there is a low rate of hydrolysis because the enzymes are partially denatured. And let's mention it here because we didn't go into how we've lost this tertiary structure. So let's say ionic, doesn't have a double I, ionic and hydrogen bonds, so our charge-based bonds, are disrupted within the protein. Okay, right. So we've dealt with our low pH, low rate of hydrolysis. The elephant in the room is, of course, our very high rate of hydrolysis at our optimum pH. Is another key word, optimum. They love optimum. So we have a high rate of hydrolysis at a pH of 6. As this is the optimum pH for the enzyme. So here, okay, we've talked about active site being the wrong shape. So here active site is the right shape. And if your active site is the right shape, you get lots of successful enzyme substrate complexes forming. Okay, so we have the highest number of successful collisions between enzymes and substrates. So now we have described and we have explained. So what do we see and why is it like that? Okay, so obviously I do a lot more talking and I go a lot slower when I am teaching these questions rather than doing them. So I reckon that we shall continue this for next week because it's a really important section and a really important grounding in understanding questions. I've got 2 more enzyme questions that we can work through for next week in the same thing, dissecting the question down to pieces and then working through all the answers and looking for that model answer, that how best would you thoroughly answer a question like this. Okay, so less than 60 seconds left. Have you got any questions that you want to add in here quickly? Okay, so why don't we add the other values of pH? Because they're in between. Okay, so we're looking for the extremes in this case. So we could actually do an answer just on the zeros and the maximum. That would still cover our 5 marks. So we've added in the mediums in between just for that sort of totalness of answering the question. But we're not going to work through all of them saying it gradually and gradually and gradually. We need to highlight phases. Okay, so whenever you're describing or explaining, you're highlighting phases of your graph.